Welcome to my hands-on lab series. This is part one. My name is Russ Maxwell. It's been a little while since I've posted anything, so hopefully I'll change that and I'll be posting more videos for you. But in any event, this is part one. In this first session, you're going to hopefully set up an Azure function. It's going to be Python based on the new V2 programming model. So this is a high-level view of the lab you'll be going through. The blue arrows represent requests while the orange arrows represent responses. So we start off with the user making an HTTP request to an Azure function. This triggers execution of that Azure function, and it'll call into Azure Key Vault and request two secrets. These secrets represent the SQL authentication credentials. So these credentials will have read and write access to the database. The Azure function receives the secrets from Key Vault, and next it connects to SQL and provides the credentials and requests data from a table. Once the Azure function receives the rows from SQL, it will return the results back to the user. This lab is 100% hands-on, and you will build everything from the ground up. You will need an Azure subscription and some basic Python knowledge. If you need a Python refresher, go check out Brocode's channel. He has an excellent video covering Python basics. These labs focus more on the development aspects of an Azure function and less on the infrastructure. This will require an Azure subscription, but you will set up an Azure SQL database, an Azure Function App, as well as an Azure Key Vault. Within the description of this video, I provided links to my GitHub repo to walk you through the creation of an Azure Function App, an Azure SQL database, and finally an Azure Key Vault. You will need to provision each resource in that order. Also, I included a local machine setup guide based on a Windows client. Go ahead and pause the video, set up your Azure infrastructure, come back, and we'll continue. Okay, welcome back. Hopefully it wasn't too painful to set everything up, but let's run through real quick just to make sure we're on the same page. What you have set up matches with my setup. So first off, let's go into the Function App. And the main thing here is to ensure that you have the manage identity set up. So if you were to go into identity, you should have this on, and it should have an object ID that you can use. What else? You should also have Azure Key Vault set up, and in your Azure Key Vault, you should have permissions granted for the managed identity. So if I come in here and I click on role assignments, you can see I do have the Azure function ACLed here, so it can access, and it's provisioned with the Key Vault secrets user role. In addition, if I look at secrets, you should also have these two secrets set up, which represent the credentials required to access SQL, because we're using SQL-based authentication. And then if we go over to SQL, if I were to bring up SQL Management Studio, which is part of the setup, you installed it and you set up that table, right? This is the table we're going to be fetching results from. And so you should have this table set up, the inventory table, and it should have these entries, right? Obviously, modified date is going to be a little different for you. So in addition to the table, we also want to verify that the user that we created, it has the appropriate database roles. It should be DB writer and DB reader. And so to do that, number one, you can see I've expanded the database, I've expanded security, and I have the user that should be present. In order to see what roles are applied, I can run a couple system views. I'll go ahead and add this query to the description field so you have it. If I run this, you can see I get a healthy response back, DB data reader, DB data writer. So we're in good shape here. Let's continue. Let's talk about the local machine setup. These steps are for Windows clients. First, you'll need to download and install Python. I'm downloading Python 3.9. However, the Azure Function V2 programming model supports up to Python 3.11. Has the date of this recording. So as long as you build your function app to run Python 3.11 runtime, you can also download and install Python 3.11 instead of 3.9. Next up, obviously you'll need VS Code installed and the Python extension the Azure extension, and then very important, the Azure Function Core tools. And these are super important. It will provide the runtime environment that allows you to build and run your Azure functions locally. Next up, you want to install Node.js. You need to install Node.js because it's required by the AZU write extension. Because Azure functions require a storage account, you'll want to install the Azure write extension, which is an emulator that acts as a storage account running locally. Now the fun begins. So now we're in VS Code. And first thing is you're going to need to create a blank folder somewhere in your local file system, which I've already done. So I'm going to open that folder, file open folder. I'm going to get to that location. I'm going to select that folder, Lab 1, and I see it in my Explorer view here. Now I want to create my Azure function. So in order to do that, I should have my Azure icon here. So I'm going to select that. Underneath the workspace window pane, local, I'm going to select the Azure function icon and then create function. I'm going to select the current folder. I'm going to select Python language. We're going with the model v2. I'm going to select my locally installed Python version 3.9. And then here you can select what kind of trigger you want to apply to your Azure function. In my case, we're just going to use an HTTP trigger. Going to need to give it a name. I'm going to name mine Lab1 Func, F-U-N-C, enter. And this is the authorization level controls. Your options are function, anonymous, and admin. I chose anonymous. And really these levels, it specifies the level of authorization required to run the function. Anonymous means anyone can trigger this function, and the other two options require an API key. So I'm going to choose anonymous. So you can see it starts with creating a virtual environment. What is a virtual environment? Why is it necessary? You can think of it as a container for your project dependencies. So dependencies are your packages you're installing via pip command. And with a virtual environment, those packages are installed directly to the project's virtual environment folder. And this provides isolation. So I can have multiple projects and VS Code with each containing their own dependencies. If you don't use a virtual environment, when installing a package, it gets installed globally and available across all your projects. Not using a virtual environment. Use it. It's good practice. And now we have a Python function created. So I'm going to close the preview. If I go back up to Files or Explorer view, you can see I've got these files listed. Let's spend a minute talking about this directory structure. So starting off, we have the virtual environment. We also have the VS Code. It contains your VS Code configuration. You have the funcusr, and that specifies files that shouldn't be published to Azure when deploying the function. The getignore works in a similar fashion. You specify the files that are going to be excluded when publishing the solution to a GitHub repo. The function_app.py file, that serves as your default entry point and contains your functions to be called when the Azure function executes. So yes, you can have multiple functions in here. And we'll talk about that in a moment. The host.json file, it contains a bunch of options that are pushed up to Azure when the solution is deployed. So for example, health monitoring, application insight settings can all be configured here. The local.settings.json file is used to configure settings for running your function locally on your system. So some Azure functions require a storage account, which is why you have the Azure write extension. You do have some options in this file, and it'll instruct the functions to run locally by specifying the local storage emulator. The requirements.txt contains any Python packages that'll be part of your project. So for local development, you can manually install your packages with pip. However, I like to add my packages here, which I'll do in a moment, and you can point pip installer to this file to install your modules. So this requirements.txt will facilitate downloading and installing the packages that are part of your project. Let's validate the out-of-the-box Azure function that was created when we built the function. Runs locally. To do that, we need to launch a terminal session. We need to activate our virtual environment. BNB scripts activate. Okay, it's activated. Now we need to run our pip install, and we need to point it to the requirements.txt. So use pip install with the R switch and requirements.txt. I already had that installed, but you won't, so you should see it download and install. Next up, let's go to the local settings JSON file. I've already set this value, but you will need to set it in the Azure Web Storage. Set it to this value, use development storage equals true. And that instructs this function to leverage the Azure local storage emulator. Next, we'll need to launch Command Palette and ensure that the Azure services are running. So we go to View, Command Palette, and Azure Start. Okay, those are started. One way to validate is if I refresh. I've got some JSONs listed here. I'll hit Control S to save these settings. Hop over to the Function App PY and let's run it. And you can see the endpoints created for me on my local host. So I just have to get to this directory in the browser in order to trigger the execution of the function. I'll paste in that endpoint. It triggered successfully, pass a name in the query string. To pass a name, I can just do something like this. Question mark name equals, we'll just say Fred. That comes back, hello Fred. So we're good here. Let's go back. We'll take a look at one more thing on this function. So the first thing I wanted to point out is this, we're calling logging.info. That is super helpful because you can log messages directly to the terminal. Here you can see I've logged this message, this Python HTTP trigger function processed a request. Okay, now we get to dive into the development aspect of this. Let's build out our Azure function, and I'll start by canceling this current run. Let's head over to requirements.txt. We first need to add the packages we'll use for our project. A Python package is a collection of one or more modules. And a module is a single file or collection of files imported that are any combination of classes, functions, or other Python objects. When you run pip install, you're typically specifying a package. So here we're going to add our packages that we're going to be using. So first one, we will use pyodbc. That's a package that's going to help us work with SQL data. Next up, I'll add Azure Identity. And that package is used for authorization and access to various Azure resources. All right, last but not least, we'll need to add the Azure Key Vault secrets package. I'm going to save this, and I've already installed these packages, but assuming you haven't, need to run pip install with the R switch requirements.txt. And it'll take a little while, but it should install for you. Let's head to Function App PY and start importing these modules. I've already added my imports, so you can see line 3, I've imported the pyodbc module. And line 4, from the Azure.identity module, I'm importing the default Azure credential class. And then finally, from the Azure.Keyvault.secrets module, I'm importing the secret client class. The rest of this code is out of the box, and we're going to change this. But starting just to kind of recap the out of the box functionality, here we're grabbing an instance of the function app. We're passing that auth level I talked about earlier, anonymous, as a parameter. Down here, line 11, this is important. So the @ symbol app.route, this is a decorator. Azure V2 functions are decorator based. In Python, decorators extend the behavior of the function, and they're callable. Decorators are callable and usually take another function in as input. In this example, we're calling a decorator instance of the function app class and passing in the route. The route decorator sets up the route for the HTTP endpoint. In this example, the endpoint is lab1func. If you used V1 Azure Functions, you didn't see decorators because those details were stored in function.json file. The function itself takes an HTTP request as a parameter and returns an HTTP response. So this is line 12 here. If you're confused by this right arrow, that's called type hinting, and it indicates the value type the function should return to the caller. So moving into the body of the function, I'll talk briefly about what this is doing. Line 15, we're working off that request object. We're retrieving the name parameter. If it doesn't exist, we're going to grab the JSON from the request body, and then we're going to try to get the name from that request body. If the name does exist, we're going to write a simple message to the screen and pass that parameter that was inputted by the user. Let's start implementing our logic. First off, I only want to execute the code I'm going to write if the name parameter equals magic. So it's pretty easy. Just going to do name equals magic here. I'm going to give myself some real estate. So what's the first step? The first step, again, we want our Azure function to retrieve secrets from Azure Key Vault. So I'm going to put a comment here. Getting secrets from AKV. So we'll start with a try. We want a good exception handling. I'm going to call this the Key Vault URL because that's what we're going to have to call first. I'm going to specify my Key Vault endpoint. So I need to pass that. I believe it's labakv.vault.azure.net. We might have to come back and change that. Because I don't like the red squiggly line, I'm just going to add my except block now. For an exception caught, that's fine. Next up, I need to do credential equals default Azure credential. This is a magical line of code. So depending on where you're executing your application matters in this case. For local development, when I run this line of code, it first tries to use my cached credentials. If I don't have any credentials cached, it's going to launch the browser so I can authenticate. And those credentials will be cached and used from that sign-in. So before I run my app locally, I usually like to log in using the Azure extension or with Azure CLI using AZ login directly in the terminal session. Again, this is super awesome for local development when testing code against various Azure services in the cloud. In this example, when the app is deployed and running within Azure, the default credential will leverage and use the managed identity to obtain an access token in order to gain access to Azure resources. So it does have multiple uses depending on where it's running from. Next, I need to create an instance of the secret client class. And I'll pass the Key Vault URL and the credential that'll connect and authenticate to Key Vault. So I'll assign the results to client, and it's pretty easy to do. You just call secret client, and my vault URL will equal my Key Vault URL, and credential, I'll assign my default credential to it. Now I need to fetch the two secrets that represent my SQL auth credentials. We'll start with the SQL username, and we call client.getSecret. And the secret I want to retrieve is the SQL user, and I want to retrieve the value. And I want to do the same thing for the password, client.getSecret, and pass in the name of the secret. In this case, it's SQL password. Go, and I want to retrieve the value. Now we have the secrets assigned. Notice I've updated the except logic, and so you can do the same. Instead of using print, I'm using logging.info, and I'm informing the terminal that there was an exception caught getting secrets from Azure Key Vault. Next line, line 38, I'm stating that there was an exception caught, so I'm responding to the HTTP request, notifying of the exception, and then the program is exiting. Actually, I'm going to remove quit because we'll never get to the quit because we're actually we're actually returning back. So we're handling the exception properly. We're in the execution of the function, just on the pure fact that we're sending a return back. So we're good there. Next up, I need to establish a connection to SQL. I'm going to add a comment connecting to SQL. And here I'm going to specify the arguments I'm going to pass in that are required as far as using pyodbc library. The first one's server, so I'm going to add labfun.database.windows.net, which is my SQL server. In Azure, I'm going to add the database, which in my case it is autos, and then the driver. What driver am I using? And to connect to Azure SQL database, I'm using the ODBC driver 17 for SQL Server. Now I'm going to establish the connection, and I'm going to drop that in a try block. I define the CNXN, which I'll assign the connection object to, and I'll pass pyodbc.connect method, and I'm going to pass in the arguments required to make the connection successful. We'll start with driver equals driver server equals server. Port equals 1433. Database equals the database name. And finally, the SQL credentials, and these are the secrets I retrieved from Azure Key Vault. We'll start with the user, so UID, and the SQL username, and the password, pwd, and we'll get the SQL password. I need to add the accept logic. How am I going to handle any exceptions that are returned or failures to connect? So the accept, I'm actually going to add the pyodbc.error, and I'll assign it as an EX variable, so I can use the EX variable. And I want to use logging info, and just mention exception caught, attempting to connect to SQL. One thing to note, by adding pyodbc.error on line 49, as long as the error is an instance of pyodbc.error, the code within the exception block executes. I also want to pass in the exception object, so I just do logging.info, and I pass the exception object in. And then finally, I want to handle this gracefully, so I want to return back and just mention that there was an exception. So my HTTP response back is caught the exception, we can't connect to SQL, and we're going to pass the 500 status code. That looks good. So now I'm hopping into SQL Management Studio because it's good to test the queries that you want to run within Python to ensure, number one, that the query is correct, and number two, that you get the results you expect back. The simple query I'm doing, right, I'm just doing a select everything from the inventory table. What we're interested in is to obviously grab all the rows, but we're interested in pulling out this information, the actual model. And the model is what we're going to print to the screen. So just a heads up there, this is just good practice to do. So here we're going to execute our SQL query, and we're going to get those rows back and work with that data. So the first thing I'm going to do is define my query. And because I only have like 5 or 6 rows, this is not a huge performance hit. Obviously, you're going to want to have a more refined query if you're dealing with thousands of records in your SQL table. Next thing I'm going to do is define a list, and I'm going to store each model has an element in this list. So I'll start with an empty cars_model list. With pyodbc, I've already gotten the connection object, so now I need to define a cursor object, which is going to be used to execute my queries. I'll use the with statement because I want to gracefully dispose the cursor object when I'm finished. And so that's what this with is doing. CNXN, it's my object, has cursor, and then I want to execute that. All records query. Next, I want to fetch all the rows. So I do rows equals cursor fetch all. The cursor fetch all function, it returns results from SQL as a list of tuples. Each row from SQL maps to a specific tuple, and each field value from a given row maps to a specific element of the tuple. Next up, I need to iterate through each row, so I'll use the for statement for row and rows. And I want to log that row to the screen, so I'll do logging.info and pass row. And then I want to append the, the third element of each tuple. So each row in this case is a tuple. So the third element is the model. And so I want to do car underscore models, which is currently an empty list. And I want to add the third element, which would be a 2. Last thing I need to do is specify my accept. So in case there's a problem fetching the results, same thing here. And I will do a logging.info to the screen. I'm also going to log the exception object itself. I'm going to return the function back. All right, so if there's a problem executing the query, I also want to return back. I also need to add the final return statement from this try, assuming it's finishes correctly. So on the same line as with, I'm going to add my return statement, and I want to return that car models list. So it'll look something like this. Response. And I'll need to pass the list within brackets. So if I pass the magic name parameter in, I also need to have an else statement here. What am I going to do if somebody does not pass magic has the name parameter? So I need to add that at the very end. And I'll do another return. And you didn't pass the correct name though. Try again. Okay. And I will pass the status code of 200 because it was successful. It's more of a user input error. Okay, I'm going to save that. So it doesn't look totally good yet. Decided to look at this closer. You can see I've got this the title of the py file in red. Over on the left, I've got 2 here, so that indicates there's a problem that it's detecting. So if I look to the right here, I see this red line come across, so I can click on that to get to the bottom. I've got an extra else condition that I didn't expect. So this is left over from the out-of-the-box functionality, so I don't need it. I'm going to remove it. Also, this line 93, I don't need it either, so I will remove it. And that looks good. Okay. So now we're in a green color. Green is good. Let's go ahead and run our function locally to make sure that it works before we deploy it to our Azure Function App. To do that, there's a couple things I want to do first. Remember I talked about the default credential, how it will use cache credentials. I like to get that going first, so I'm going to type in AZ login. It's going to launch a browser window off to the side, and after I log in, it looks like this. You have logged in, so I'm good there. And down here, you can see it logged in successfully. So I do have my credentials cached. That's good news. The very last thing I'll do is ensure that the Azure Write emulator is running. So I will go to View Command Palette, and it's right here at the top, Azure Write Start. I'll click on that. That's now running as well. So we're good. Let's go ahead and run this function. All right, it's running. So I just need to hit the endpoint here. Okay. And let me drop that endpoint in. And noticed it detected that I didn't pass in the correct name. So what was the name I needed to add? Magic. And you can see it's spinning, so it is running. And that's not good. I've got the Air 500 back. Let's see what's going on. So here at the very bottom, the exception is line 68. That's where it starts. And the exception itself is a type error, unhashable type list. So looking closer at this, yes, the HTTP response, one type I know will work as far as a return statement is a string. So I need to use an F string so that I can basically stringify the car models list. And to do that, it's pretty easy. Just type F here, and I need to wrap the car models bracket in quotes. That'll pass the car models as a string. So let's close the function. We're going to run it again. Okay, it's running. Let's just hit enter again on this endpoint. We're good. So you can see we've got our car models back. So successful test locally. That's great news. Let's come back and see. We also were logging, we're printing out to the terminal via the logging.info, and we have those entries here of all the rows. We have our success at the very bottom. So great news. Let's move on. We have tested locally with success. Let's deploy this to our function app. So in order to get here, I had to click the Azure icon on the navigation pane on the far left. You could also hit Shift-Alt-A. After sign in, I just expanded my subscription function app, and I found my function app here. To deploy my Azure function, I'm going to right click the function app and deploy to function app. You'll get a prompt. Are you sure you want to deploy? Yes, I do. It didn't take too long to run. I've got success. Let's go inspect the Azure function. All right, I'm in my function app in Azure portal. You can see under the overview page, I have my Azure function listed here, and it's enabled. If I know the endpoint, I can add to this. I can just append it to my URL to my function app. Another way to do it is if I click the function, there should be there's an option called get function URL, and that's going to give me the path to the API itself. So I will use that, and let's hop back into my browser, and I dropped in the endpoint. I also added name equals magic here. So let's run it, and we're good. So we're done. The main thing, obviously, after publishing the function to the function app, remember the default credential at that point is now referencing the managed identity to call in the Azure Key Vault to get the secrets in order to authenticate to SQL and retrieve those results and persist them to the browser window, which is what we see here. So you made it. More labs to come. I probably won't be as verbose in future labs because I did a lot of basic explanation of the Azure function and building one here. So see you next time. Thank you.